Hi friends, welcome back to our channel. This is Kishore Parvalsa. Today we are going to discussing about instrument transformers. Coming for the instrument transformers, the combination of potential transformer and current transformer, which is referred as instrument transformer. Okay. So coming for the current transformer, which is also called a step up voltage transformer at secondary side, but at primary side, which is used to find the line current at the transmission lines. Okay, so coming for the construction point of view, the current transformer which is connected in series with the transmission line at secondary side, which is connected to load. Okay, here load is nothing but at secondary side ends, which is connected to an ammeter. Okay, to measure the current, how much amount of current will be flowing through the entire transmission line, that can be found with the help of ammeter. Coming for the potential transformer, which is used to measure the voltage any two phases of transmission line. So in current transformer, the primary entire winding two terminals which is connected in series with the entire transmission line, as well as coming for the potential transformer, the primary winding two ends which is connected across the two phases of the particular transmission lines. So that is the difference between current transformer and potential transformer. Okay, so coming for the basic construction point of view, here let us consider this is like a transmission line. Okay, the primary winding of the current transformer which is connected in series. Okay, like this. So this is the primary winding end. Let us consider this is like a R phase. For example, if you want to consider three phase transmission line, for example, if you want to go for potential transformer, the primary winding two ends. Okay, so let us consider this is one end and this is another end. Primary winding two ends which is connected across any two phases. So like this, we can finally get into the line voltage with the help of potential transformer. Coming for the construction of current transformer here. Okay, here N1 is the number of turns of primary winding and also N2 is the number of turns of secondary side winding. Okay, here the primary winding which is connected in series with the transmission line. Okay, so here the current flowing through the entire line can be measured with the help of current transformer. Secondary side which is connected to the an ammeter. So here we are connecting primary winding at the line side. Ultimately, how much amount of current flowing through the entire line can be calculated at the secondary side of the ammeter. Okay, so that's why which is called as step up voltage transformer. And so here V1 is the input applied voltage as well as V2 is the secondary side voltage. Okay, V2 is the secondary side voltage. And also coming for the potential transformer construction point of view. Okay, here input supply which is given as some line voltage VR and also the secondary winding two ends which is connected voltmeter. Okay, secondary end side we can calculate voltage and also here the secondary side which contains less voltage and high current in case of potential transformer, because of here the when compared to primary winding the secondary winding turns is less, so that's why which contains low voltage as well as high current. So that's why the potential transformer which is also called as step down voltage transformer. From this diagram representation, the transmission ratio can be here easily found out here. So from this potential transformer you can calculate to the transmission ratio. Okay, so that is given as here N1 is the number of turns as well as N2 is the number of secondary turns as well as V1 is the supplied voltage as well as V2 is the secondary side voltage. So from that we can represent as a transmission ratio. Okay, V2 by V1 is equal to N2 by N1. Okay, so this is the transmission ratio of the potential transformer. Okay, so coming for the combination of both current transformer as well as potential transformer, let us see that main diagram. Okay, this is the total entire representation of both potential transformer as well as current transformer. Okay, so the combination of both potential transformer as well as current transformer, the resultant output we are getting power. Okay, so that is given here. Because of here by the potential transformer the output we are getting voltage, combination of, so by the product of both voltage as well as current, resultant we are getting power. So that power can be measured with the help of wattmeter. Okay, so if you are observe this diagram you can clearly understood one thing. Here this is the potential transformer according to representation, two ends which is connected between the any two phases of primary winding and secondary winding ends two ends which is directly connected to coming for the current transformer, the two ends of primary winding of transformer which is directly connect to transmission, and also the secondary winding two ends directly connect to an ammeter, and finally which is fitting into wattmeter. Okay, so by the combination of both voltage as well as current resultant, we are measuring the power at the wattmeter instrument. So this is the entire overall representation of instrument transformer. Okay, so I think you are understand what I'm saying, and next class we are going to discussing with a new topic. Okay, until then keep watching all classes videos. Thank you.